students, today we will discuss about the electric field due to infinite plane sheet of charge, and we will also discuss about the electric field between the parallel sheet of charge. So first let us consider the electric field due to infinite plane sheet of charge. Let us consider a sheet like this. If this is the plane sheet of charge, now this is the positively charged sheet. If the positive charge is uniformly distributed over its surface, now the positive charge is distributed over this surface and back surface both. If we have to calculate the electric field, then if we have to consider the Gaussian surface, we have to take the help of Gauss law. So we have to draw the Gaussian surface. If we draw a Gaussian surface like this is the Gaussian surface. This is a cylindrical Gaussian surface which is penetrating the sheet and moving in this direction also. So here if we talk about the electric field, the direction of electric field will be in this direction, EA, the electric field will be in this direction. Now here also the electric field will be in this direction. Now if we talk about the area vector, suppose that the area of this circular section is A. So area vector will also be in this direction, and here also the area vector will be in outward direction like this. Now if we talk about the curved surface, the area vector will be in perpendicular direction to the electric field. Now this is the area vector, this is the electric field, the angle is 90 degree. So if we talk about the flux is in E dot dA, that is a closed integration of E dot dA, that is equal to E into dA cos theta. Now the curved surface, the electric field is normal to the area vector. So the electric flux due to curved surface will be 0. So electric flux will be due to this surface and this surface. So total flux will be E into A plus E into A. The total flux will be 2EA. This is the total flux. Now if we talk about the Gauss law, now the electric flux will be 2 into EA. If we talk about the Gauss theorem, so by Gauss law, the total flux phi is equal to Q upon epsilon naught. This is the total charge enclosed by the surface. Now if we talk about the total charge enclosed by this surface, suppose that sigma is the surface charge density of this surface, then we know that the surface charge density sigma is Q by A. Q by A, that is equal to surface charge density. So here if we talk about, if we put this value 2EA here, so it will be equal to 2EA is equal to Q upon epsilon naught. So that is equal to electric field will be E is equal to Q upon 2 epsilon naught A. Now Q by A is surface charge density, so it will be written as sigma upon 2 epsilon naught. Now this is the electric field due to infinite plane sheet of charge. Now if we consider two parallel sheets like this, if we look this figure and consider two parallel plane sheets like this is a two parallel plane sheets, this is two parallel plane sheets having surface charge density sigma 1 and sigma 2. Now this is the region first, this is region first, this is region second, this is the region third, where we have to calculate the electric field. Now to calculate the electric field, the basic concept is that we have to put the positive charge there, and we have to point the direction of force that point. In that direction the electric field will be. So here if you put the positive charge here, this is the positive charge Q1, is the surface charge density sigma 1 having positive charge, so it will repel this positive charge in this direction. So E1 due to sigma 1 surface charge density will be in left direction. If we talk about the sigma 2 is again a positive charge, so it will also repel the positive charge in this direction E2. Now the net electric field E is equal to E1 plus E2. The net electric field, now both are in left direction, so left direction, the net electric field will be in left direction. Again the formula of electric field due to infinite plane sheet of charge we have discussed is sigma upon epsilon naught. So it will be equal to sigma upon 2 epsilon naught. So it is equal to Q upon 2 epsilon naught A. So here it is written as sigma E1 is sigma upon 2 epsilon naught plus sigma 2 E2 is sigma 2 upon 2 epsilon naught. So it is equal to sigma 1 plus sigma 2 upon 2 epsilon naught. Now this is the electric field, now both are in left direction, so it is in left direction. Now if we talk about the region 2, if you put again a positive charge here, the sigma 1 will repel this in this direction, E1 will be in this direction, the sigma 2 will repel this, the E2 will be in this direction. Now, if we consider the right hand side to be positive, left hand side to be negative, like this, if we talk about this side is positive and this side is negative, then here if we talk about the net electric field, it will be equal to E1 minus E2, then E1 will be sigma 1 upon 2 epsilon naught minus E2 is sigma 2 upon 2 epsilon naught, and both, it means that sigma 1 minus sigma 2 upon 2 epsilon naught will be the net electric field in region 2. Now, whichever is greater, whether sigma 1 will be greater, if sigma 1 is greater than sigma 2, the electric field will be in this rightward direction. If sigma 2 is greater than sigma 1, the electric field will be in leftward direction. So if we talk about the region 3, again if you put a positive charge here, the sigma, the q1, the surface, this positive charge will repel this positive charge, so electric field will be even in this direction. Now this sigma 2 will again repel the positive charge, so E2 will be in this direction. So net electric field E is E1 plus E2, so it will be sigma 1 upon 2 epsilon naught plus sigma 2 upon 2 epsilon naught. So if we add both these, then we find a sigma 1 plus sigma 2 upon 2 epsilon naught, that is towards right. That is, the electric field is towards right. So this is the electric field due to two plane sheet of charge in three regions, first, second and third. Again, if we consider the three plane sheet of charge, like this three plane sheet of charge, if we consider like this, the three plane sheet of charge, if we consider like this, if we put three plane sheet of charge having charge plus q, minus 2q and plus 3q. Now here we will not talk about this, we will not talk about the electric field in terms of surface charge density, we will talk about the electric field due to charge. So if again, if this is the three region, if you divide it, this is region 1, this is region 2, this is region 3, this is region 4. If we divide in this region as A, B, C and D, and we have to find the electric field at A, B, C and D, then again we will put a positive charge here. Now this positive charge will repel this, so electric field due to EQ charge, it will be leftward direction. Now this is minus 2q charge, it will attract this, so here the electric field due to minus 2q charge will be in rightward direction, it is minus 2q, again plus 3q charge is there, so it will again repel this, so it is in this direction, so it will be again E3q. So if we have to calculate the net electric field, then E will be E minus 2q. Again, if you have to consider the rightward to be positive, leftward to be negative, so E2q will be positive, minus EQ minus E3q. Now this is the net electric field. Now when we put the value, this is the value is q upon 2 epsilon naught A, so it will be equal to 2q upon 2 epsilon naught A. It will be minus q upon 2 epsilon naught A. This is minus 3q upon 2 epsilon naught A. Now this is minus q minus 4q minus 4q minus 2q. It will be equal to minus 4q plus 2q, it will be equal to minus 2q upon 2 epsilon naught A, that is equal to q upon epsilon naught A. This is minus direction, so minus direction is left, so electric field will be in left direction here in region, this region. If we talk about region B, again we put a positive charge here, again this positive charge will repel this positive charge, so EQ will be in this direction, E minus 2q will attract this positive charge, so E minus 2q will be in this direction, E3q is positive charge, it will repel this positive charge, so E3q, the electric field due to 3q charge will be in leftward direction. So net electric field will be E is equal to EQ plus E minus 2q minus E3q. Again we are considering the rightward to be positive, leftward to be negative. Now again this is EQ, so it will be q upon 2 epsilon naught A, E minus 2q plus 2q upon 2 epsilon naught A, minus 3q, it is minus 3q upon 2 epsilon naught A. Now this is 2q, 2q, 3q, 3q, minus 3q plus 3q, it will get cancelled, so net electric field will be 0 in this region. in region B. Now if we talk about the region C, again we put a positive charge. This positive charge will repel this in this direction, so it will be EQ will be in this direction. Minus 2Q will attract this, so it will attract in this direction, so it will be minus 2Q, and plus 3Q will again repel this, so the electric field due to 3Q charge will be in leftward direction. So net electric field will be E is equal to EQ minus E2Q minus E3Q. Now if you put the value, then E is equal to Q upon 2 epsilon naught A minus 2Q upon 2 epsilon naught A minus 3Q upon 2 epsilon naught A. Now this is minus 3Q, this is minus 2Q minus 3Q minus 5Q plus Q will be minus 4Q upon 2 epsilon naught A. This will be minus 2Q upon epsilon naught A. This is the net electric field. Now this is the minus sign, and we have taken minus sign as leftward, so electric field will be in left direction. Again, if you talk about the region D, then again if you put a positive charge, then positive charge Q will repel this, that is EQ will be in this direction, minus 2Q will attract this, so it will be minus 2Q will be in this direction, and this 3Q will repel this, so 3Q, the electric field due to plus 3Q charge will be at one direction. So again the net electric field will be EQ plus E3Q minus E minus 2Q. So again if you put the value, this will be Q upon 2 epsilon naught A, this is 3Q upon 2 epsilon naught A, now minus 2Q upon 2 epsilon naught A. Now this is the net value of Q2 plus 3Q, 4Q minus Q minus 2Q, that will be equal to 2Q upon 2 epsilon naught A, that is equal to Q upon epsilon naught A. Now this is the positive, so direction will be rightward.